Here we go. So today we're going to be talking about concavity and inflection points, okay? These are going to be really big words for if you take a calculus course, okay? An inflection point is where a curve changes from being curved upward to being concave upward to being concave downward, okay? Or vice versa. It's just that when do you stop increasing and start decreasing? That's our inflection point. Got it? As you get further into calculus, you will learn how to algebraically find that. But right now, we're going to be just working on being able to identify it. Cool? All right. So when we talk about change in the slope and the direction, so slope is increasing. I know you think slope just means a linear equation, right? So you're like, but miss, this isn't a line. And I'm like, no, it's not. It's a curve. There is a slope at every point. So if you notice here, the slope at this point is doing this, right? It's going like this. The slope here, there's a slope here, there's a slope here, you see that's the slope. So when we're talking about a slope is increasing, you're looking at the slopes of the points that are given, okay? Not a line, because clearly this isn't a line. All right, notice here the slopes are decreasing. So we start here, and then the slope does then the slope goes and then it keeps going and going. So the slopes are now decreasing. Does that make sense? Yeah. All right, so this is a concave up, because my slopes are increasing at points. This is a concave down because my slopes are decreasing at points. Cool? All right, let's talk about looking at it from a graph. So first up, I need this thing to minimize. Okay, so it says use the graph here. This is g of x to show at right to determine intervals of concavity and state the points of inflection. So first thing we're gonna do is identify our points of inflection. Our points of inflection are found by finding the averages of our x's from a high to a low. So currently right now, this is our minimum point, right? And this is our max, agree? The x value here is -3. The x value here is 2. Because I'm going from min and max, that means an inflection point lies between these two. And you find that by finding the point in the middle, which just means you're finding the average, right? What is -3 plus 2? -1. And what is -1 divided by 2? -0.5. So this is right here, we're going to call it a POI, a point of inflection. Was that terrible to find?
Yes.
I'm sorry, the horror of it all. Okay. I did. All right, so now we're going to find our another point of inflection. Inflection? I don't know why I keep wanting to say it. So I know. I was like, what am I saying? That's what I keep thinking I'm saying. Why am I saying that? Inflection, not infection. Inflection. Okay. Okay, hold on.
Here for this.
All right, here we go. So our next one, we have another max and another min. So this max takes place at x equals 2. The min takes place at x equals 4. What is 2 plus 4? What's 6 divided by 2? So where's our point of inflection? Right here. This is our POI. Okay, super easy. How do we feel about finding our POIs? We got it? We can do that? It's terrible. No, it will not always have a dot. Okay. All right. So, yes. Yes, ma'am. All right. So we're going to talk about where is it concaved up. Okay. So when we're looking for where is it concaved up, we're looking for when our function is doing what? It's going down and then it's going up. Our slopes are doing what? Our slopes are increasing. So we start here, this right here. So from negative infinity up until our POI, we are concaved up. Do we see this? So we would write, we are concaved up from negative infinity to negative 0.5. Okay, where else are we concaved up? There you go. Perfect. From 3 to positive infinity is our other concaved up position. Okay, where are we concave down? When is our curve going?
From the two, from the first, the POI to the POI.
From one POI to the other POI. That's where that curvature happens, right? That we are going concaving down.
So why would it be from two, like the max to the min?
You're going through the max. So we're going through the max. So we're going from one POI to the,
It's not like intervals.
it's not like intervals, exactly.
Negative 0.5.
So we're at negative 0.5 to 3. Because everything is defined by the X. Well, the POI, but by the X value of it, right?
Why?
Because X is your independent variable. It controls where you're going. Okay. So the points of where our concavity starts and or stops, that's where we call those are our POIs. Does that make sense? Minus infinity. So our POIs are at negative 1/2, comma, negative 3. And our other one's at 3, comma 1. So we did an example where the points were plotted for us. Now we're going to do an example where the points are not plotted. Is that okay? And we have to find them. All right. You'll be fine. You got this. Okay. So first we're going to identify our POI. So the first thing we're going to do, we're going to find our where they're at. So we're going to identify our max. Here's our max. And here is our min. The POI lies somewhere between these two, correct? So we're -2 plus 1 is what? -1, right? Half of -1 is -0.5. So we know that we're at X equals -1/2. Agree? Now we're going to find what value is at -1.5. That's what it is. So we're going to substitute that to find the exact value of the POI. By substituting, we're taking our -1/2 and we're going to substitute it into our equation. So we have 2 times -1/2 to the third plus 3 times -1/2 squared minus 12 times -1/2. I know I could, but I chose to write it in fraction form because I want y'all to understand that fractions are our friends.
Not at all.
Fractions are our friends.
Fractions can like also grow.
3, 2, 1. Yeah. Right here. They came from here. 3, 2. Okay. So now we have to evaluate, right? We're gonna challenge ourselves and do this without a calculator.
No.
Oh, no.
Are we ready?
No.
I believe in you. Here we go. I don't have enough room, so I'm gonna do it at the bottom down here. So 1/2 to the third.
What?
What's 1/2 to the third?
Wait, no, an eighth? No,
An eighth. There we go. It is a -8. So we have 2 times -1/8. Why? When you have a power on the outside, it applies to the numerator and to the denominator, right? And 1 to the third power is just 1. 2 to the third power is 8. Okay? Because it's a negative and an odd, it's still going to stay a negative. All right, we're going to do it again. Here we go again. So -1/2 to the second power is what? That's going to be 0.14, right? 0.25, 1/4. Okay, now we have -12 times -1/2. What is half of -12? And it's a negative times a negative makes a +6. Look at us doing this math in our head.
Oh, yeah.
You did it. You got this. Now we're going to keep going. So we have 2 times negative 1/8. The 2 only applies to the 1. So it becomes negative 2/8, which is what? 1/4. Okay, plus, and then again, the 3 only applies to the 1, so that makes plus positive 3/4. And what's 6 minus 4? You're 1/4, because a negative times a negative makes a positive, because you had negative 1/2 squared, which means you have negative half times negative half, which makes it a positive. And that gives us positive 2. All right. Where are we at now?
We combine the negative.
We combine, and what does this make? A half, so our answer is 2.5. You did it. So our POI is at negative 1/2 and 2.5. Can I write 2.5? Is that okay? Okay. It's in the card over there. All right, so it says state the intervals where your function is concaved up and concave down. Where are we concaved up? Where are we smiling?
From the infinity.
Negative half to and is where? Remember, it's based off of your POI. So where's our POI?
In the middle.
This is our POI.
of the two.
What is the X value of our POI? Negative 1/2. So we are concaved up from negative 1/2 to positive infinity. We are concave down from, you start from left to right. So from negative infinity to our POI, which is at negative 1/2. So from negative infinity to negative 1/2. Yes.
Why can't you just do the same thing for y that you did that?
What do you mean?
Just to get, make it average.
Take the average, because it doesn't always work out that way, that your Y values aren't gonna necessarily always be half of each other. Yeah.
So what's the C?
A concave up and concave down.
Okay.
I didn't have enough room to write them. I could have drawn arrows, I guess. Up and down. Okay, how do you feel about being able to find concavity?
It's okay.
It's okay?
I walked about 3 birds, so I'm walking off the main.
You gained some, let's be honest. Okay, so that's gonna be our page 4 done. Yeah?
I just wanted to know that.
All right, so we're gonna move on to intercepts.
Down on the